Okay, so we're back. So where were we? We were right here. Okay, so we were saying that because this comes from the derivative, we can plug it into the non-derived equation, which I'm going to write over here. In place of k, we're going to substitute 1 over 3x squared. So 1 over 3x squared times x cubed equals x plus 1. Okay, so the x squared, well, here, let's just write it out. It's x cubed over 3x squared equals x plus 1. Okay, so you get x over 3 is equal to x plus 1. Multiply both sides by 3. You would get x equals 3x plus 3. Move the 3 over, move the x over, you get 2x equals negative 3. So that means that x is equal to negative 3 halves. Oop, went off the paper or the screen. Okay, so you get x is equal to this. So now that we know exactly what x is equal to, now we can plug it back into this guy. So we say k is equal to 1 over 3 times negative 3 squared, negative 3 over 2 squared. So that becomes 9 over 4 times 3. Times 9 over 4, right? So what that means is that k has to equal 27 over 4, all under 1, which means, I'll just write it out. 1 over 27 over 4, which is equivalent to saying 4 over 27. And that's what your k is equal to. Okay, so there will be a problem like that at the end of the test for a bonus. So if you understand this process, you should understand how to do the bonus. Questions? Okay, thanks for reminding me. Yeah, because I had to refresh and so I lost track of the chat. So 67 and 70. Okay. So it's the same one, but now we're going to do 67 and 70. It's still page 116. Okay, so page 116, 67. So k over x. F of x is equal to, I'm going to write 70 so I can remember. F of x is equal to k over x. And the tangent line in this case is y equals negative 3 over 4 x plus 3. Okay. So once again, start out with k over x is equal to negative 3 over 4 x plus 3. Take the derivative of both sides. And so in this case, k is a constant, so we just take it out. So we get something like This is x to the negative 1, so it becomes negative 1 over x squared. Yeah. So in other words, it becomes negative k over x squared. And that's because you have this x, you have this k x to the negative 1. So bring the negative 1 over, subtract 1, turns into this. Okay, take the derivative of all this stuff, it gives you negative 3 over 4. Probably the quickest way in this case would be to cross multiply. So you get negative 4k is equal to negative 3x squared. Because you got these negatives on both sides, you can just say 4k equals 3x squared. Divide, or here we can take care of it now. Divide both sides by negative 4, so k is equal to 3x squared over 4, right? Okay, once again we found k, so we're going to plug it in over here. So that means we have, yeah, we'll do it here. Actually, we'll do it up here. You have 3x squared over 4 divided by x is equal to negative 3 over 4x plus 3. Okay, now this guy right here is the same thing as saying 3x squared over 4 times 1 over x, meaning one of these x's will cancel out. So you get 3x over 4 is equal to negative 3x over 4 plus 3. Add 3x over 4 to both sides. That would give you 6x over 4. So 3x over 2. X over 2. When you add you add 3x over 4 to both sides. So you would get 3 over 2. It's 6 over 4, which reduces 3 over 2 equals 3. Multiply both sides by 2. Divide both sides by 3. And you should get what? 3? 6 divided by 3 is 2. Oh god. Did we freeze up again? Okay, no we didn't. Well, not on my screen anymore at least. Okay. Good. On my screen it froze up, but we're good. Okay, so x equal 2. So because x is equal to 2, we plug it back into here. Okay, so you get k is equal to 3 times 2 squared over 4. So effectively k is just 3 because the 4's would cancel out, right? So k is equal to 3 in this case. Okay, so let's go ahead and do 70, unless there are any questions on that one. Such a long process for a simple answer. Yes, that is calculus, and it's going to get much worse next lap. So 70, let's work 70 out. So what is 70? 70 is k times x to the 4th. And you have 4x minus 1 is your equation. Okay, so f of x is equal to kx to the 4th, and your tangent line y is equal to 4x minus 1. Okay. Okay. So here's what I have on this one. So same process. These two are equal to each other because they have to be continuous. No, or they have to be continuous at that point of tangency is why they're equal to each other. In other words, these two intersect at that point, right? You have some curve that looks, I don't know, like that, and you have your tangent line which intersects at just one point and one point only, right? So that's also why we can say that these two are equal to each other, because they're intersecting at that point. Will there be anything on the test like 137, 113, 117, 118? I'll look at those in a second once I'm done with this one. 113, 117, 118, on page 116. We'll check those in a second. Okay, so you say these are equal, take the derivative with respect to x. And so you get k times 4x cubed is equal to 4. Okay, divide both sides by 4x cubed, you get 1 over x cubed. Okay, now that we have that, then we can say 1 over x cubed times x to the 4th equals 4x minus 1. These cancel out and give you just x equals 4x minus 1. Move the 1 over, move the x over. You get 3x is equal to that. So that means that x is equal to 1/3. Did I do that right so far? I think so. Okay, now you plug this bad boy back into here. And so you say 1 over 3 cubed. This is the same thing as saying 1 over 27. So in other words, k is 27. Yeah, it's because it's 1 over. Okay. See, you were asking if there's any like 113. Kinda, but not really like 113. I mean, 113 is very interesting if you understand how to work it, because there's a couple things that if you understand what, yeah, let me show you what I'm looking at. If you understand what, oh, that's not what I wanted, what this guy actually means, there's a couple things that simplify the process. 117 looks like this one. Find a and b such that f is differentiable everywhere. You know, I thought about this, and I don't really think I need to put one of those on the test. Yeah, let's work 113 real quick. So this guy, it says find an equation of the parabola y equals ax squared plus bx plus c that passes through 0, 1 and is tangent to the line y equals x minus 1 at 1, 0. Okay. So let's see how we do this one real quick. It won't be real quick, but it's okay. Number 113. So you have y equals, let's turn this down. Y equals ax squared plus bx plus c. Ax, this is an a, x squared plus bx plus c. And it passes through the point 0, 1 is what they're telling us. And then there's a tangent line, y equals x minus 1 at 1, 0. Okay, so let's see, we can find out what c is straight off from the start because it's saying x is equal to 0, so these terms cancel out. So in other words, c is equal to 1 if you substitute these two numbers in. So you already know that c is 1. So that makes it a little easier. So now we're doing the same exact thing that we did on the last 3 problems we just did right now. So in other words, ax squared plus bx plus 1 is equal to x minus 1. Okay, so that means a times 2x plus b is equal to 1. So we can say b is equal to 1 minus, we'll say a 2x or 2ax. Okay, I wasn't very clear here. We took the derivative of this thing and got that. Okay. So we can plug in b over here and then solve for a, I think, if I'm not mistaken. So let's see, we'll plug in b, and so we get, let's work it out over here. Oh no, let's keep working down here. We'll get ax squared plus, we don't have b anymore. So what we have is 1 minus 2ax times x plus 1 for y, right? Y equals that. So y equals ax squared plus x minus 2ax squared when you distribute this x over plus 1. So ax squared minus 2ax squared means you have y equals negative ax squared plus x plus 1. Now, once again, we know that we have this point, so let's plug that point back in now and solve for a. So x is 0. Oh, that doesn't really help us, does it? We know that this point should work, right? Yeah, we know that this point should work because it's on the curve, so we can use this point in this place. So let's say that y is equal to 0. The point was 1, 0. We can say y is equal to 0 and x is equal to 1. So negative a times 1 squared plus 1 plus 1. So that would mean we can move this a over and just say a is equal to 1 plus 1, which is 2. Okay, now that you have 2 for a, you can plug this back into this guy up here. So then we can say that b is equal to 1 minus 2 times a, which is 2, times x. So b is equal to 1 minus 4x. So let's plug this back into this guy. We can say now that y is equal to 2x squared, because a was 2, right? 2x squared plus b is 1 minus 4x. Yeah, we'll just say that. 1 minus 4x times x plus c. Oh, c was 1. Okay. Sorry, I just noticed your question, Kim. Since you plugged in 1 for x the first time, can't you do the second side and say b is equal to 3? Am I overthinking it? Let's see. Because if your way got the same answer, then yeah, let's use your way. 2x squared plus 1 minus 4, oh no, plus x. Gotta distribute the x. Minus 4x squared plus 1. Y is equal to negative 2x squared plus... I don't know what I'm doing here, because if we do this, we're going to get this thing. However, hold on. Since you plugged it in here, can't we plug it in here? Because if that's the case, then we could say that b is equal to 1 minus 4, which would be negative 3. This seems very unnecessary because it's going to take us nowhere in the end. So yeah, why don't we say that it's negative 3? Did I do this one for the homework? Let's see. Yeah, I did do this one on the homework, and I did make this a lot easier than I am doing it on screen. So let's look at that real quick. Let's add, actually here, add a window capture 2, I'll do that one. Okay, and let's look at this right there, at this part. Okay, so we are looking at this stuff right here. Let's see what I did in the homework problem when I was actually thinking on my feet. It says y is equal to ax squared plus bx plus c, and 0, 1 is a point of the function, so c is equal to 1. We established that. Also, y is tangent to x minus 1 at 1, 0. So if y is equal to that, that means that y prime is equal to that. So because they're tangent, right, we established that 2ax plus b is equal to 1. Yeah, we did show that. Where was it? We showed that right here, 2ax equals plus b, and that b is equal to 1 minus a, right? So here we go. 2a plus b at 1, 0, yeah, 2a plus b, so it means b is equal to 1 minus 2a. Plug this into y. So yeah, we did that. We worked backwards, and we got y is equal to this. Oh, here's probably where we should have acknowledged that fact. If we would have just kept it in terms of a and b, after we did this, we wouldn't have had to do the x business. Yeah, because that would have eliminated the x business, and we could have just worked with a's and b's, right? So then we can say 0 is equal to that, so a is equal to this. Then you plug that into b over here, so that would be make b -3. So your equation looks like this. Yeah, so basically I was overcomplicating it. I think this step was necessary. However, we should have just plugged in. I'm talking and I'm not showing you what I'm talking about. This step was necessary. However, once we did this, we should have plugged in this point up here to just eliminate the x's and the y's altogether and have everything in terms of a's and b's, so you could just solve then at that point, blah, like that. Because yeah, then we would have said a is equal to 2, 1 minus 2 times 2. We wouldn't have to worry about this x because we already plugged it in or whatever. So it'd be 1 minus 4, which is b equals -3. So that's why you get y is equal to, you get y is equal to 2x squared minus 3x plus 1, right? Dumb. Okay, I have room for maybe one more question. Am I frozen? You said we'd review finding dy dx at point xy. So find one on the homework where we do that, and I'll work that one out. Let's see. Because I'm just going to look through the PDF and see if I see any that look like that. They're usually the ones, here we go. It's page 120, no, that's ugly though. That one has to do with secants and stuff. Do I want to do one like that? Find the derivative of the function and evaluate at that point. Yeah, let's do number 62 on page 127. Page 127. Oh, wait, what? 29 of 146 work. No. I don't know if it would. But I like this one, because this one looks like it might be more relevant to the one on the test, to be honest. Number 62. So let's work this one out, because yeah, I feel like it's more relevant. 127, page 127, number 62. Okay, so it says f of x is equal to sine of x times sine of x plus cosine of x. And it wants you to evaluate at pi over 4, 1. That's your point. Okay? No, I'm not going to show you the TM test problem. But I will show you a question that is similar to the one on the test, which is this one, number 62. Okay? So let's see. Let's go to the actual problem on my paper. Okay, so let's find the derivative of this stuff. So you have something times something. So that means you have a product rule, right? So that means that f prime of x in this case is the derivative of the first thing, which is cosine of x, times the second thing, which is sine of x plus cosine of x. So f prime times g plus f times g prime. So f is sine of x times g prime. So what's the derivative of this stuff? Well, the derivative of this stuff is cosine minus sine. Right, the derivative of the first piece is cosine, the derivative of the second piece is negative sine. So that's why it goes from this to that. Okay. So let's go ahead and distribute these because it might actually make things look nicer. So this is cosine times sine. So I'll call that sine x cosine x. This is cosine squared plus sine cosine minus sine squared. So maybe that didn't make things look any better. Well, I don't know. Hold on. I may be speaking prematurely. This is 2 sine cosine plus cosine squared x minus sine squared x. Now we know that the identity is cosine plus sine, not cosine minus sine. So we can't change that, but we can change this guy here. So shoot, I don't remember off the top of my head. That's sine of 2x, right? Okay. So sine of 2x is equal to that. Plus cosine squared x minus sine squared x, right? So that's what f prime of x is. Okay. So at this point, let's just go ahead and plug in our x value, pi over 4. So what's f prime of pi over 4? Well, it's sine of pi over 4 times 2, which is pi over 2, plus cosine squared of pi over 4 minus sine squared of pi over 4. So sine of pi over 2 is 1 plus cosine of pi over 4 is root 2 over 2 squared would be 1/2 minus, same thing, root 2 over 2 squared becomes 2 over 4, which is 1/2. So f prime of pi over 4 is just 1. Okay, and so this would be dy over dx at xy. Okay, so let me move my pen. It's in the way. 8 lines of work to get 1. Basically, right? So, yes, hint, hint, you do need to know your unit circle for the test tomorrow. I mean, not that you don't know it at this point, right? No, the whole test will be like that in the sense that, yeah, you have multiple lines of stuff just to get one question. But this one question, I think it was number 11, is a trig function Okay, here. Cosine squared of pi over 4. This is cosine of pi over 4 squared. What's cosine of pi over 4? That's square root of 2 over 2 squared. That is 2 over 4, which is 1/2. Everyone's tripping all over the place. Oh my God. Oh goodness. What? Stop. What are you doing? What are you doing? Guys, that's not my hand. I get to school at 6:30-ish, but I'm gonna say 6:50 at the earliest. You like my nails or her nails? I think you're talking about her nails. Oh my God. Alright guys, so yeah, thanks. I'm gonna go ahead and stop the stream just so that I can save the video and give Twitch a chance to archive it if it hasn't already done it, and then let me restart it and I'll talk about the PC in a second, okay?